It's a very important as a student. I feel like they are the inspiration for you. Such things, no, such concepts, no, they are inspiration. They'll help you a lot. Oh, so they'll help you to lot to understand the science. Okay, there's a heat engine. This is the working substance. Now, what do you mean by working substance? Ideal gas. Okay, what is there's a odd body. So I'll write it here. There's a odd body. It was at temperature TH. The temperature of this, let it be TH or T2. Anything you write it. There's a cold body. Temperature T1 or TL. Okay, TL, higher temperature, lower temperature, TH, TC, whatever symbols, cold body, let me write TC. Now, what actually, it has to do mechanical work. This is something very important, no? Which I'll be using for work done by the gas. So what it should do, this particular gas should absorb heat. From where it should absorb heat? From the hot body, and it will give it to the cold body. And this is the mechanical work. This is very important. The mechanical work is very important. So this, I'll write it nearby. What do you mean by work done by gas? Mechanical work done by the gas, the meaning. So what it does, it will absorb heat, QH, I'll write it, and it will reject heat, QL, or to the cold body. So what is that QAB? QAB is QH. Okay, let's retain that symbols. QAB is what? Heat absorbed, no? From the hot body. Heat rejected to the cold body, QL. And T1, T2 is what? Temperature of the hot body. TL is what? Temperature of cold body. Okay, sir, fine, you have changed some symbols. We have changed symbols here. So how this particular engine has to work out here? I will try to give diagrams. Huh? These are very important to understand what actually this engine. Huh? Okay, now first, where is the temperature of gas at A? It is, so the piston, there's a piston. So what is the volume of gas? Will be VA. Temperature, let it be T1. Okay, temperature, okay, what we took. Okay, this symbols. This is T1. Correct? No, this is T1 higher temperature. Yeah. Hmm. Okay, now it's a temperature T1. This is, so first what happened for this gas? Heat should be supplied, no, because it has to undergo isothermal process. So I should supply heat. From where I should bring heat? So for that purpose, open, I need a source. So what is needed now? A source is needed. So here I will join a source. I think we'll go for. I'll attach a source here. So what it does, it will, what is the temperature of source? Will be T1 or TH, anything you can write it. So here the source what will supply energy to the gas, where the gas will absorb heat at constant temperature T1. Then what process it should undergo? It should undergo isothermal process. So what I should do, I should attach a source. So I think this you'll find very difficult. Okay, let me say that we have supplied heat. No. So what will happen to the gas? It will undergo isothermal expansion. I think let me finish off first diagrams, then I'll come to isothermal expansion. And then these diagrams are missing. So let me help you with the diagrams. Adiabatic expansion. Yeah. After adiabatic expansion, VB, VC, then VD should come. VD. After this, it should be okay. No, just will what all things are then I'll indicate here. I'll supply heat. So on supplying heat, what happens? The gas will absorb heat at constant volume. So here Q1 amount of, or select a QAB is what supplied. I'm explaining graph, then I'll come for this one. QAB is nothing but QH, later on we'll write it. So first what happened, this piston now, this is ideal gas. So the gas will absorb heat at constant temperature. The gas will absorb heat at constant temperature. It will absorb heat at constant temperature. It will undergo isothermal expansion. Tell me where do it will be now? Volume of the gas will be VB, temperature will be T1. Fine. Isothermal expansion. Then what shall I make? I should make the gas to undergo adiabatic expansion. Then the volume of the gas will become VC. The temperature will become T2. So what is the process it will undergo? Adiabatic expansion. Should it absorb any heat? I should not permit it to exchange heat. I should not permit the gas to exchange heat. The gas, what happened, will push the piston, and because of that, what happened, the gas does positive work, and it will have come to this one. Okay, now it is here. So now what I should do? I should extract heat from the gas so that it will come to the position VB. Temperature will be T2. So here what we should do? We should take out heat. Who will take out heat? I should bring a sink. I should bring a sink, that one. Sink is what? Which will absorb heat. Okay, fine. So now what will happen? The gas will undergo isothermal. Okay, so sorry, this is. Fine. So here it will be isothermal. So it will undergo compression. Then afterwards, what will happen? I should permit the gas, exchange agent should come here, no? Because again, the volume of the gas, I should bring it to this one. So here what should happen? Adiabatic expansion should occur. The exchange agent should push the piston such a way that, so what should happen to the gas? It should undergo adiabatic expansion. So exchange agent will come into picture. So what actually happens? I should supply heat. Who will supply? A source. Or in an odd body, what we say, it should supply heat. And I should make the gas to undergo isothermal expansion. For that, the temperature of gas must be maintained constant. Then next afterwards, I should permit the gas to undergo adiabatic expansion on its own. I should not do anything, but I should see that no heat exchange should occur. Then again, what will happen? Here, the isothermal compression should take place. For that, what happen? I should take out heat. I should take out heat from the gas. Then it will undergo at constant temperature, isothermal compression. Then an extrusion should push the piston in such a way that it should undergo adiabatic compression. It will come back to original cycle. Like this, what happened? This is one cycle. Like this, what happened in engine, petrol or diesel engine, like that, some 30 to 40 cycles will take place. Just imagine. So what happened? A source should come in contact. It should supply it. Isothermal expansion. Then I should remove the source. I should see that no heat exchange should occur and it should undergo adiabatic expansion. Getting the idea? Then again, what will happen from adiabatic expansion? So here what will happen? I should bring a sink which should absorb heat from the gas. Get it? It should absorb heat from the gas. Then undergo isothermal compression. I should remove that sink. Now extrusion agent should push the piston so that it will come back to its original state. This is one cycle. So are you looking at the engine? So whenever you switch on engine, we do get a sound, no? Mechanical sound. Car, vehicle, anything vehicle, no? Mechanical sound. Why do that mechanical sound? Because inside the piston, no? There the things will be moving. Source will come in contact, source will be removed. Sink will come in contact, sink will be removed. Like this, moving parts are needed. So in 1 second, like this, 30 cycles will take place. Just imagine how much effort they have made engineers, no, Western engineers, they have made to construct such an engine. So because of this, here what happened? You can see mechanical work. Are you seeing now? I supply it, it does mechanical work. Here also till here mechanical work. So in this region, what will happen? The engine will do mechanical work and anything which is connected to piston will also move. Like that, what happen? I'll set up a torque. This moving piston will set up a torque. Due to torque, the wheel will rotate and the vehicle will move. This is the background of our engines which are there in our vehicle. This is called like a heat engine. It's, you can say it's a revolution. It has changed our life. Because of this engines, no, we have all these vehicles. Okay, this is the odd body. If you are getting confusion, you can also call it as a source. What do you mean by source? Which will supply heat. What do you mean by sink? Which will absorb heat. So to construct heat engine, what you needed? You needed a source. What is a source? Which will supply it. I'll burn petrol. When I burn petrol, what do you get? Energy. That heat will be supplied. And we need a sink which will absorb. So inside that engine open, a sink will be there. Heat will be rejected. Okay, able to understand now? So now this efficiency depends on what? Depends upon the source and sink, independent of the gas. Are you looking at this? I should attach a source here. Source is attached. I should bring a source which will supply heat. The temperature of source will be the temperature of the gas it will become. And it will supply it at constant temperature. So now the efficiency depends on what? Not on this cylinder, piston, not on this gas. It depends on the source, external agents these are. By varying these temperatures of source and sink, I can control the efficiency. What are these? These are in not degrees Celsius, they are in Kelvin. They are in Kelvin, that one. So therefore now the efficiency. So we can also write this as, let me rewrite this. Eta T1 minus T2 by T1, which is equal to 1 minus T2 by T1. Or this is temperature of cold body by temperature of hot body. Okay, this is what the efficiency is, what we define like this. This efficiency of the Carnot's heat engine. So what is the advantage of it? What is the advantage of Carnot's heat engine? Eta is independent of nature of gas or independent of nature of gas or nature of working substance. Is it okay now? So is it a monoatomic, diatomic? Let's not bother. What gas you fill up, we are not bothered now. Eta is independent of nature of gas or nature of working substance. There's the one thing. Now eta depends on temperature of source and sink only. Getting the idea? So there's a one. What about the maximum efficiency? Can we have efficiency 100%? TC equal to TH. If TC equal to TH, efficiency will become how much?
0.
0, no, efficiency not possible. So what is the maximum possible efficiency? That is the efficiency given by the Carnot heat engine. So therefore, by varying the temperature of hot and source and sink, we can control the efficiency. I need not to bother, but the gas should undergo this cyclic process. It's a must. I think it's very difficult to maintain such a thing, sir. It's not that easy. Is it a reversible cycle? Yes, it is Carnot, because what all we discuss all are reversible cycles, no? Irreversible, not possible. But practically what happen, what do you mean by irreversible? The gas can never perform same operation, means now it will undergo isothermal expansion. If you take out heat, it will never undergo the same process. It cannot retrace path practically. Any reason for that? Because there'll be friction will be there. The gas is ideal, not it's not an ideal. So what all in practically all the processes are irreversible. Theoretically, we'll call it as a reversible and we'll try our level best to make it irreversible. Sorry, reversible. All practically what happens, they are irreversible, means you make it to expand. Again, what happens if it undergoes compression, the gas will not come back to its original state with the same variables, because some energy will be lost because there'll be friction between the piston and the cylinder. So therefore what happens? Practically all the processes are irreversible. Theoretically, what happens? We are making it reversible. First we'll design it. Then what all the energy that are lost now, I'm going to supply it. I will make it approximately reversible. So shall we put it, reversible cycles have more efficiency than irreversible one? Definitely no, because in irreversible what happens? There'll be friction, there'll be loss of energy. So therefore, what we can say, reversible cycles have more efficiency than irreversible one. What about Carnot cycle? It's a reversible one. Now, compared to all, Carnot cycle will have maximum efficiency. I think I'll write some points which are very useful. Reversible cycle as more efficiency than irreversible one. One more point. Carnot cycle is a reversible. What do you mean by reversible? I think you have in chemistry discussion, where the gas will have the same features when it isothermal expansion and isothermal compression. It should come back to its original state. Practically not possible. Means I'll supply 10 joules for isothermal expansion. Then if I take out 10 joules from the gas, it should undergo isothermal compression to come back to same state. Practically not possible because of friction between the piston and the cylinder. The gas is not ideal, will be real. Carnot, this last statement is very important. Carnot cycle as the maximum efficiency in all cycles. Switch off video, ma. Switch off video. Carnot cycles has the maximum efficiency in all cycles. So this is the one. Okay, of all very important, the efficiency is independent of gas or nature of working substance. I need not to bother monatomic, diatomic. And the efficiency just depends only on what temperature of source and sink. The temperature of odd body is called as source. The temperature of cold body is called as the sink. When Carnot heat engine will call source and sink. By varying temperature of hot and cold body, what happens? We can control the efficiency. Last one more point by varying temperature of such a thing is possible in like a ordinary cycles what we discussed. Never, no, it was a fixed value. We did so many problems, the efficiency was a fixed here, but here what happened, I can control efficiency by varying the temperature of source and sink. There's an advantage because I want to control on the parameters, no, physical parameters. That's why the Carnot heat engine is what preferred. Okay, temperature of hot body, temperature of cold body. So these are the things. Okay, just see once all. Will have any doubts, you can clarify it. Any doubt, you please ask it because I'll start the numericals one. Okay, any other formulas can you suggest? This efficiency, what was the formula we have started? Okay, let's go back. Q positive by Q negative, no? Shall we bring also the net work done by Q positive? And what is Q positive? The QH, heat absorbed from the hot body. So this efficiency formula. So what are the formulas which we are going to take help of this one? Efficiency is equal to 1 minus temperature of cold body by temperature of hot body. And also this is equal to what? Net work done by heat absorbed from the hot body. That is QH, no? Agree this? I think these are the formulas you have to remember. Please remember them. Very important. Anybody wants to ask? Okay, let's do one thing. I do have